Hello everyone. So today I'm gonna work on this wolf character which we can control. So we can basically walk around with this wolf character. So we can walk and also we can run as well. So all the animations I'm using this controller and the animation system is based on root motion enabled animations. So the animations looks good because the movement is based on the root motion displacement. So the footwork and the actual movement looks the slide in between the foot and the ground is minimum, so the turning is also good as well. So so this is what I'm going to show you how to do today. And this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. Alright, so this is our map, and yeah, so we have the wolf animations here from the animal variety pack. We don't really need to show the skeletons. We can disable it here. Right, so using these animations I'm going to create a wolf character that we can control, and everything should be based on root motion animation, so the character walking cycle would look realistic as possible. Right, so first let's see, we have okay, we don't have the third person mannequin character here. Yeah, right, so therefore let's go to add new, add feature or content pack, and select the third person and add to project. Right, now we have the third person character. Let me open it. So it's the usual third person character, and here no, if I select the third person game mode and the third person character, I can control it as usual. So now, yeah, that's not new. So let's create a child blueprint from this third person character. So let's name it third person character wolf. Now still we have this human which I don't need, so I'm gonna replace this with the wolf character like this. Alright, now let's put this and process. Here, let's process it so we can control the character. Right, now as you can see, it doesn't have any animations, but still the character can move. Okay, so yeah, let's create an animation blueprint for this. Let's create it here under animation blueprint. Let's use the wolf skeleton. Let's call it PPA wolf. Alright, now using these animations available, I'm gonna create a blend space. Create blend space, a 2D blend space. Let's call it BSP wolf locomotion. And yeah, first let's see. Yeah, all the animations with this underscore RM, those are the root motion. Those are the animations with root motion. As you can see, the character actually moves here, unlike in place animations. So let's select all of them and let's go to asset actions, bulk edit via property matrix, and under root motion enable root motion and animate first frame. So we can do this action one by one as well, but I prefer to do it this way so that I can set it at once for all the animations. Alright, now let's go back to BSP wolf locomotion animation blend space, and let's name the horizontal axis as site, and the minimum axis value I'll set -2 and maximum +2. Number of divisions 2. The reason to use this value is I'm gonna set minimum is to 0, maximum is to 2, and number of grid divisions 2. Wait, no, we need -2 here. So -2 means run into left, +2 means run into right, and we need 4 divisions. And here vertical axis, let's name it forward, and minimum value 0 because I don't have walk backward animations here. So minimum is 0, that means idle. Maximum is 2, that means running. And divisions 2. When the value is 1, that means walking. So okay. Wolf run RM here, and wolf run turn RM, let's put it here. Over here, and wolf turn RM, let's put here. Let's make it here. Let's put it here, and then wolf walk RM should be here. And wolf walk turn RM, let's put it here. Wolf walk turn oh wait, this is right, this is left. The right animation should be here. This is also this is left. Okay. Walk turn left RM, this must be here. Wolf walk turn right RM. Where's the running? Wolf run turn right RM, right, should be here. This is running. This is wrong. Wolf work turn RM. Okay, so these are the animations. Where's the idle breathe, like this. Walk, run, turn right while running, turn left while running, turn right while running. Okay, that's enough for the blend space. Now let's drag and drop this into BPA wolf and connect like this. Okay, now let's promote this to a variable side speed, and this to forward speed. And compile. Right, now in the event graph we need a way to update these values, but still if I play the game you can see character is just sliding. I forgot to set the animation blueprint PPA wolf. Okay, now here in the third person character, as you are trying to move this character with the root motion, so here in the parent class of the third person character we have this this move forward with add movement input. So when we add movement input this way, the character does not use root motion. It actually moves the character without having to do anything with the animation. So therefore I want to override this part. So here I'll just call move forward event and also move right event like this, and I'll just leave it blank. So when I do that, you can see now I am pressing WSAD but nothing happens. That's because I haven't added any movement input here. So but here in the BPA wolf, if I set the forward speed to 1 and compile, once I play, it has the animation but it still doesn't move. So this animation is there even without pressing any movement buttons. So yeah, we don't get the animations because we because we haven't set up properly the root motion. So we need to get the settings for this. Wait, where is it? No, right, save this, close it and open again. So we get the basic settings for the animation blueprint, right? And here set root motion from everything and play. Now we can see the character is moving, but I'm not actually giving any inputs, but still character is moving. So we don't need that to happen too. So I'll set it back to 0 here, and then I'm gonna define a way to get the desired movement of the character into the animation blueprint. So let's define a new blueprint interface in the BP folder. I just created blueprints BPI character movement, and then I'll define a new function, get desired movement direction. Okay, well, let's instead of movement direction, let's just call it get desired movement, and let's output a vector desired movement, right, and compile this. And in the third person character, the base third person character, I'll go to class settings and implement BPI character movement. So after doing that, under interface I have this get desired movement. So here I'll get move forward axis value and move right axis value, and I'll split this. So this move forward velocity should be applied towards the forward direction of the control rotation. So that means in case of a third person character controlled by the player, move forward is applied towards the direction I am looking through the camera. Yeah, towards the direction I am looking for the through the camera. So let's get control rotation, and with this one, where actually I don't need any x or y components, get forward vector wait, no, recombine, get forward vector. Right, now here break this and split this. So here we should only consider the yaw, because if I look up and down, that doesn't mean the character is trying to fly or submerge in the ground. So therefore I am going to use only the yaw part, and this one should be multiplied with the move forward value, because that's the actual movement value we need to apply towards the direction I am looking at. Similarly, we can get right vector using only the yaw value of the control rotation, and that should be multiplied with this vector, with this move right value, like this. Okay, now this 2 is 2 perpendicular vectors, so let's add this together, and let's recombine and return. I don't think we will have to normalize this because these two are perpendicular. Let's see about that. Right, what next? Okay, now we have a way to get the desired velocity. Now let's go to BPA wolf from the try get pawn owner. Let's first check if we have a valid pawn owner. If yes, get desired movement like this. And out of this, now we using this we can find out what is the required side speed and the forward speed in order to have this desired movement. So we can calculate like this, get the character forward vector and the right vector, forward vector and right vector. Then we can do a dot product between the character forward and the desired movement. By doing a dot product, what we get is along the forward direction of the character, what is the value, what is the component we have from this vector. So that is the forward speed. So I'll here set forward speed like this. And similarly, if I do a dot product between these two, I will get the side vector. Set side speed like this. Alright, now let's see. Now when I press W, the character moves. Now because of the character is moving with the root motion enabled animations, the movement on the ground looks good, but once I remove the key, it stops right there because we don't have any smooth thin function here. So therefore let's add a lerp, a linear interpolation with this. For the alpha maybe 0.5. Let's do the same and set this value like this. Right, now let's see. Now if I release the movement button, it stops like this, but it's not sudden as before. So right, now I'm gonna make this character run as well. So for that, in the project settings and the input, what should I use? Let's run as the key. Let's use shift left shift. So I'm gonna use I'm gonna do this as if I hold left shift, character will run. If I release it, character will stop running, so go back to walking. So that's the way I'm gonna implement this. Right, now to implement this, here let's add another event, run action run. Okay, so let's add a boolean variable running, and I'll set running to true when I press shift, and false when I release that. Now in the get desired moment, can we just multiply this with a float? Does it work like that? Let's see. A as 2, B as 1. So if I'm running, I'm gonna multiply it with 2, otherwise with 1. Okay, now when I press shift, it runs. If I release shift, it stops running. Okay, so yeah, I think we can use some work here, because when I turn, it doesn't look that good. Right, yeah, to understand that, let's print the speed side value, so we should be able to find better values for that. Okay, maybe let's just move it like this. Oh wait, this is walking, so it should be here. Okay, that's better. Okay, so this is our wolf character. So I think we can stop this episode here. Oh, we don't have the collisions there. Right. Okay, let's stop here. So if you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below, and the project file will be available for download through this page. And thanks for watching. See you in another episode. Also feel free to make new suggestions for this series as well. Thanks.